All right, class. New unit, Unit 5, similarity units. We're going to be talking about similarity between triangles and shapes. And this section is 6.1. So now I know now the numbers don't match up, but this is our 5th unit, and it's just off of Chapter 6 in the book rather than the chapters actually matching up with the units. So skipping over Chapter 5, but this is our 5th unit. So proportion. A proportion is an equation that states two ratios are equal. An equation that states two ratios are equal. So what we have, AB is a ratio. CD is a ratio. And we're stating that those two are equal. If those two are equal, then we have this proportion. The cross product property is the product of extremes equals product of means. So we can see up in our proportions that some of those letters are called extremes and some are called means. When we multiply those, we're multiplying the two extremes together, and they will equal the two means multiplied together. So we see our letters that we have. That's going from A over B equals C over D. And we're cross multiplying. So we have A times D equals B times C. So cross multiplying. That's the cross product. Product is the result of multiplication. All right, so we're talking about ratios and proportions. We need to know how to simplify ratios. Ratios can be written as fractions, but they can also be written like we have here in letter A, where it's 81 centimeters to 3 centimeters. And you can, that colon, you can say 2. So 83 centimeters to 3 centimeters. Or 83 centimeters, or every 3 centimeters, 81 centimeters, or vice versa. So we want to simplify this. And to simplify, we can write it as a fraction. So if we wrote it 81 over 3, 81 centimeters over 3 centimeters, that would simplify to 27 over 1. And then if we were to rewrite it the way it was originally, it would be 27 to 1. And notice we're also looking for that greatest common factor, the GCF. 3 being the greatest common factor, so we're able to take 3 out of each number. And when you set it up, 81 over 3, that's exactly what we're doing. We're dividing by 3. We look at B. Now we have 9 feet over 15 yards. So notice we don't have the same unit of measurement. We have feet on top and yards on bottom. So we need to be able to convert that. So if I've got 9 feet over 15 yards, and I want to convert to be able to use the same thing, I could say 1 yard is 3 feet, right? And then notice I have my feet on the bottom, which is opposite from where feet are on our original ratio. We couldn't have feet on the top there. We needed on the bottom to be able to do the conversion. So now we have 9 feet times 1 yard gives us 9. Over 15 yards times 3 feet gives us 45. And now our feet will cancel out, our yards will cancel out, and really we just have those numbers multiplying across. So now we have a ratio of 9 over 45. That's going to simplify to 1 over 5. Our greatest common factor there is 9. 9 goes into both 9 and 45. So 9 goes into 9 one time and goes into 45 5 times. And then we can write our ratio as 1 to 5. Now, how can we use a ratio to find a dimension? Let's say we're painting some barn doors. We know that the perimeter of the doors is 64 feet, and that the ratio of the length to the height is 3 to 5 feet, or 3 to 5. We need to find the area of the doors. So that's kind of like saying for every 3 feet long or 3 feet wide the doors are, they're also 5 feet high. That doesn't mean the width of the door is 3 feet and the height is 5 feet. That's just the ratio, the simplified proportion. And we need to find the area of the doors. Remember, area is length times width, or length times height. So let's get a visual. We've got our barn doors. We know we have a length of 3x and a height of 5x. We know the perimeter of our door is 64. So our perimeter equals 64. So I know 3x plus 3x plus 5x plus 5x equals 64. And then I can solve for x, and then I can be able to plug that back in to find out what my actual lengths are. And we have 3x and 5x here, because if we know our proportion or our ratio is 3 to 5, we know that that's simplified. We just need to find what that greatest common factor was that was able to get us to that 3 to 5, and that greatest common factor will be our x. So we'll be plugging that greatest common factor back in to get the full length and width of everything. So 3x plus 3x plus 5x plus 5x gives us 16x equals 64. Divide by 16, and we come up with x equals 4. So we can take x, plug it back in. 3x will then equal 12. That's 3 times 4 to give us 12. 5 times 4 will give us 20. So we have sides of 20, 20, and 12, 12. 12 and 12. So our area is length times width. Maybe make a note of that if you've forgotten. Length times width to give us the area. So our area equals 12 times 20. Area equals 240 feet squared. We do need to have our unit of measure, feet. We see that. We're using feet up here. And anytime we multiply two lengths together with a unit of measure, that unit of measure gets squared. Feet is squared. So 240 feet squared. Our area will always be squared. Example number 3, we're going to use extended ratios. So the measures of the angles in triangle BCD are in the extended ratio of 2 to 3 to 4. And we want to find the measures of the angles. So let's get a visual. Let's draw a triangle. We know we're dealing with the triangle BCD. So let's label a triangle BCD. And we know the extended ratio is 2 to 3 to 4. So starting at B, I would have 2x. Remember, 2 to 3 to 4 is a simplified is our simplified ratio. So we need to figure out what that greatest common factor was. So that's our x. And C matched up with 3, so that's 3x. D matched up with 4, so that's 4x. So we have our values for our angles there. Now we know all three angles of a triangle add up to 180. So if I have an angle of 2x plus an angle of 3x plus an angle of 4x, I know they will equal 180. So 2x plus 3x is 5x, plus 4x is 9x. So 9x equals 180, divided by 9, and x will equal 20. So then we want to take x, plug it in, to find my angle measures. So the measure of angle B is 2 times 20, which is 40 degrees. Measure of angle C is 3 times 20, which will give us 60 degrees. And then the measure of angle D is 4 times 20, which is 80 degrees. And there we have all three measures of our angles. Find the measures of the angles. We have 40 degrees, 60 degrees, and 80 degrees. And those simplify down to 2, 3, 4, if that's a ratio, 2 to 3 to 4. All right, next we want to be able to solve proportions. Solve proportions. So this is using our cross product property, where we're going to cross multiply. So if we're cross multiplying, we're multiplying 6x, 6 times x, and 7 times 30. So that gives me 6x equals 210. 7 times 30 gives me 210. Then I just need to divide by 6 to get the value of x. And 210 divided by 6 is 35. So notice you'll probably want to keep a calculator handy in this unit. You'll be using calculators a bit more to multiply and divide. For letter B, we're still going to cross multiply. Find our missing variable. We're going to solve for B. So what that looks like with 3b plus 1 times 2, 3b plus 1 needs to stay in parentheses. And then we'll have the 2 on the outside to distribute. Let's make sure this looks like a B rather than a 6. And that's going to equal 4 times 5. So now we need to distribute that 2. So don't forget to distribute. So 2 times 3b gives me 6b, plus 2 times 1 is just 2. So 6b plus 2, 4 times 5 is 20. Then I need to solve for b. So subtract 2 on both sides. I have 6b equals 18, divide by 6. And b equals 3. So cross multiply and solve for the variable. Right, that is it on the notes. 6.1 homework.